this is just amazing. So recently, while back in the UK, I found my old astronomy notes, which go all the way back to at least 1986. But this observation here from 1991 is the one that really does sort of date itself. 17th of January, Thursday, day we attacked Iraq. And that's my drawing of Mars on that day. And Mars was actually pretty small. But anyway, so later on, we're going to check how accurate that observation was, because, yeah, Mars, it's not like Jupiter, which, well, observations of Jupiter here somewhere as well. Observations of Jupiter. Whatever. I've got observations of Jupiter here somewhere, which are also fairly cool. But, you know, with Jupiter, the clouds are always changing. With Mars, not so much. Anyway, so what really dates this is just how much astronomy has changed, since the, late 1980s, when this was the sort of apex of, the chemical photography is exceptionally hard for these sorts of things. You know, if only because you've got to wait, you've got to take the pictures, you've got to send them off to be developed, and only then can you start on the learning curve. It's not like now where you sort of push the button loads and, you know, if you get something that's good, or you can, recover it sort of digitally. And also way back then, I couldn't afford anything, right? Which will become very evident later. So I wanted to take some longer exposures of the stars, and that was the mount that I was going to make it with. Never quite got around to making it, but then there's this. This is the dreams of the day. And what stuns you when you look back at this is just that this is before there were go-to mounts. Nowadays, you take a look at these things and there's basically no wedge on these things. And they're just on go-to mounts. You get some field rotation issues with some of the astrophotography, but other than that, they're much easier to set up. And so it's just amazing. This was the earliest sort of go-to mount. And these I had absolutely zero chance of affording. Zero. These were the things that I poured at mournfully at night. Realistically, this was more my bracket of stuff that I could afford, which was about £300 for the refractor, which is really fairly limited, and £400 for the equatorial mount. I lusted for those throughout my childhood, and then down here, 8-inch Dobsonian, £300. Guess what I ended up going for? I mean, in the end, it was an absolutely fantastic decision, because it's all me sort of getting to grips with stuff. And there's some quite nice little ray diagrams of, Newtonians. Newtonians need parabolic mirrors, which is why they're expensive. Whereas if you come down to the Schmitz, they're spherical mirrors, which are much cheaper. But of course, you need a corrector plate. So you have either a Schmidt corrector plate or a Maksutov type corrector plate. And there's mirror mounts and all sorts in there. Anyway, so other things that are in some ways kind of cute. This is the only record that these flecks of space dust ever existed. These are drawings of where meteors went and roughly how bright they were, the time and the date, 1987. Damn. So yeah, that was a fleck of dust hitting the Earth's atmosphere at 10:23 on the 11th of August by the looks of things. And there's a few pages of these telling you how bright they were and all that sort of thing, complete with hand-drawn bloody star maps. It's incredible. And some observations of Jupiter. Galileo, eat your heart out. It doesn't actually say what year those were, but these were really fairly early on. There you go, that's how you remember the moons of Jupiter. I eat gammon cutlets, Io, Europa, Ganymede, and Callisto. And that's actually pretty decent for the geometries of the orbits. You know, Io is, you know, about a Jupiter diameter out, Europa a bit further, and you know, the orbits get longer as you get further out. And obviously this is when Jupiter was near quadrature, which meant that you got a bit of shadow. You get a bit of shadow on one side of Jupiter. Very small amount. There you go. And, oh my God, there's the date. What's that say? 17th of September 1987, and a drawing of what Jupiter looked like. So these really changed really quite a lot over the years. And it was one of the things that infuriated me, that when I started, I always wanted to see the Great Red Spot. Come on, focus. I always wanted to see the Great Red Spot, but when I started observing, the Great Red Spot had faded till it was almost non-existent, which meant I just had, you know, days, or well, nights and nights of observing. Was in the perspective, 5:30 in the morning. Yeah, I would very, very commonly stay up all night. Yeah, only go to bed once the. I think this is all done by hand. Damn. There we go. On to some deep sky observations of the Omega Nebula. Now, there's a whole. The galactic center is actually fairly far south, so you get really lousy views of it from the UK. And my God, I mean, the effort that went into drawing these. There's a whole bunch of nebula near the galactic center, or you know, looking towards the galactic center, and they were so hard to find because of the sky glow that we would get in the where I lived in the UK. Eagle Nebula. Yeah, so this one basically, come on, focus. That was as good as it got. It really was. The Eagle Nebula has very low surface brightness. And you combine that with lousy skies, and there's zero chance of seeing it. That's the Sombrero Galaxy, which is another one that looks pretty. You can only ever see half of it. With again, Virgo is quite far south, so globular clusters look spectacular. These are all done with a, does it tell you? Yeah, 8 3/4 inch. This is my Dobsonian, and then you know how to find it. Actually, little paintings of it. My God, the effort. So as he went through and checked some of these, you know, see how accurate they were. In fact, I've got the Orion Nebula. The dumbbell. Actually, yeah, so these are actually pretty decent, sort of, you know, what you expect to see. Yeah, how to find it. Yeah, there's this little M thing that you look for when you're trying to find the Dumbbell Nebula. It's super easy to find, and super bright. Crab Nebula, supernova remnant in Taurus. Double cost. Drawing all those stars. The Rosette Nebula, zero chance of seeing that. Again, this is another one of those really low surface brightness things. So low surface brightness, you have zero chance of seeing it unless you've got really, really good skies. And we only have had mediocre skies, I would guess. Here we go. A couple of pairs of galaxies in Leo. Yeah, so there's a couple of galaxies over there and a couple of galaxies down here, all relatively bright, you know, 9th magnitude. I'd have zero chance from seeing these where I live at the moment, but yeah, it really doesn't matter what size the telescope is. If the sky glows with as much brightness as these really faint objects, you just can't see them. The Eskimo Nebula in Gemini. Anyway, so there are two things that I wanted to come to here. The first one was my observation of Mars, which was done, when was this? 17th of January, at basically 8 o'clock in the evening. So I've now pulled up Celestia, and it's now on January the 17th. Yeah, that's right, 1991 at 8 o'clock. And now we're going to go to Mars, right? So this is basically what Mars looks like. There we go. So there's Mars. And let's see how that compares to my drawing. Oh, it's upside down. That's one thing. Okay, so you've got the Terminator, right? There's a bit of Mars that's chopped off. So in that sense, it's not so bad. And yeah. You need quite an eye of faith to, I mean, you get some of these spiny patterns, but, so Mars can change with dust storms, but, yeah. maybe not the most spectacular. Well, you can see why Lowell thought he saw canals on this thing. Anyway, so that's that one. And somewhere at the end here, I had a picture of the Orion Nebula. There we go. This looks hopeful. There we go. Orion Nebula. And I also have the picture of the Orion Nebula. And so the trapezium in the center. Let's see if we can actually get this one out. Take a look at that. The Andromeda Galaxy as well. The amount of effort that went. Right, so the Andromeda Galaxy is actually huge. This is really only the nucleus of the Andromeda Galaxy. You take a picture of it, and it's all the way out here. And there are two little satellite galaxies, one up there, one up there. Yeah, both fairly easy to find. Anyway, so what do we got? You have these three bright stars and the trapezium, and so one side of the trapezium points at one star, and I mean, bear in mind these are just drawn from the eyepiece. You know, it's not bad, and you know, arguably you take the bottom of the trapezium, you come to this guy out here, which is a bit of nebulosity, which is, you know, basically that. So it's about, oh, I can't focus on both. It's about there somewhere. Anyway, so, no date on that. Yeah, the Andromeda Galaxy. Yeah, this is, you have to scroll the telescope around the field of view on the telescope. Is you can never really get the whole Andromeda Galaxy in. But this is something else that I would do. Oh, my word. Right? So by far the simplest way to get into astrophotography. This was back in the day of chemical film, by the way. Right? So these are the actual pictures on the roll of film, the lens that you were taking it with. You would basically point the camera at a fixed point in the sky and take an exposure. If you get much more than about 10 seconds, you'll start to see trailing. And then, yeah, this is what the pictures were actually taken of. And you then had to send it off to be developed, which was, for me, expensive at the time. And you would see how good they were when they came back, a few days later or something. And here we go, astrophotography. And I really, really quite got into this. Nowadays, it is immensely easy to do astrophotography. The digital cameras are much more sensitive and easy to diddle around with than the chemical film ever was. So, with the Evey Scope thing, you can basically mirror what that does with just a digital SLR and just taking a few second exposure on a driven mount. Back in this sort of day, you would have to sit there and guide it, with a guide scope for 15 minutes. Yeah, and just touching the telescope and all your stars would all of a sudden be jerked around all over the place. The whole work could be lost simply by touching the telescope or, just not paying attention to the guiding for a little while. So anyway, I thought that was absolutely fascinating. I mean, especially the, you know, how much the telescopes have changed in, yeah, the tubes themselves. These are basically exactly the same as they ever were, but the mount technology has just come on in leaps and bounds, as has the you know, the digital aspect of all of this. So cool. Hope you enjoyed that. If you did, drop a like on the video, and see you next time.